plastic everywhere, not a fragment to decompose. Our carbon and fossil fuel-based conventional plastic would not degrade except in 1,000 years and continues to pile up both on land and in water bodies. The Great Pacific Garbage Patch, spanning straight from the west coast of North America to as far as the island of Japan and measuring about 20 million square kilometers in area, provides alarming evidence of this. In 2022, the CO2 global emissions amounted to about 10 billion tons of carbon, and the numbers have risen ever since. It is high time, then, that we turn towards the most pressing question of contemporary times: how to defossilize our energy and material streams. Carbon, the fourth most abundant element in our atmosphere, is crucial in sustaining life forms. It exists harmoniously with plants, animals, and humans in a relationship called the carbon cycle. But the carbon cycle is destabilized when millions of years' worth of carbon is excavated from below the Earth's crust and reintroduced to the atmosphere in the form of fossil-based fuels, materials, chemicals, and plastics. If we talk about adding to the carbon in our atmosphere, it only gets added when it was not already there before. Therefore, only when it is brought into the atmosphere from below the Earth's crust. If atmospheric carbon is recirculating in the atmosphere, then there is in fact no addition really. Therefore, the only way to get to net zero is actually to seriously go towards bio-based materials. Coming to plastics, not only are traditional plastics fossil-based, but they are manufactured through an energy-intensive process, which is also usually fossil-based, and plastics do not degrade in the environment under any conditions, but continue to lurk further beyond their use in our lives. In this bleak scenario, PLA offers us a ray of hope. How? PLA is manufactured from bio-based sugarcane feedstock. Like every other plant, sugarcane absorbs CO2 through photosynthesis and converts it into organic matter. Once harvested, sugarcane is processed to extract sucrose. This sucrose is then fermented to derive lactic acid, which in turn is polymerized to produce PLA. PLA is compostable under ISO 17088 conditions, which makes sure that can never linger on in our atmosphere as long as fossil-based plastics. The biogenic carbon is eventually released back into the atmosphere. Unlike the carbon released by fossil-based plastics, this biogenic carbon is a part of the short-term carbon cycle, preventing any excessive leftovers of carbon and making the carbon cycle neutral and probably even negative if we consider the CO2 sequestered by sugarcane in its growth cycle. Additionally, the manufacturing of PLA has shown a significant reduction of about 68% in the emission of global greenhouse gases and a reduction of about 65% in the consumption of energy as compared to its fossil-based counterpart. Over 350 million tons of plastics are produced per year. If all fossil-based plastics currently produced were to become bio-based, it would require 1.23% of the global agricultural land, leaving sufficient land for biofuels and food crop production. The Indian government has emphasized sustainability and green growth as building blocks of the country's broader economic strategy. This is articulated very well in the new BioE3 policy, which was approved by the Cabinet in August 2024. Shifting to bio-based plastics like PLA will help us take a positive step against climate change and thus ensure a cleaner and greener planet for our future generations.